A submarine launched ballistic missile is fired from a distance of 3,000 kilometers. If the Earth is considered flat and the angle of launch is 45 degrees with horizontal, find the velocity with which the missile is fired and time taken by SLBM to hit the target. So let's make a rough schematic diagram to understand it. So suppose here is the target and this is the point of launch pad, and a missile is fired to hit the target and the angle is 45 degrees. By the way, they are lucky that their target is only 3,000 kilometers away, because this is the maximum range of this missile. If the target goes away even a little bit, they will never be able to hit the target with this missile at least. If they bring another missile with a larger initial velocity v than this one, then of course they can hit the target, suppose here. So they are lucky that their target is exactly at the maximum range. So it was fired with certain velocity v, and they want us to calculate this initial velocity v, and they have given us the range or distance of the target from the launch pad, which is 3,000 kilometers. Angle is also given 45 degrees, and our task is to calculate the initial velocity v and the time of flight. So let's go to the solution. Here I have once again divided the screen into two sections so that I can do relevant calculations in their sections. It is a good approach to manage the problem. So let's do first the calculation for the velocity v, and then we can do the calculation for the time. We can't calculate the time of flight at this moment because we don't have v. So we need to find v first and then we can calculate time. So let's calculate the v. We have these two formulas. Actually, these are not two formulas. It is the same formula but just in two different formats. So we can use any of these formulas. So I will pick up the first one. And I will rewrite this formula. I will reverse the sides just for the convenience. 2v squared sine of theta cosine of theta over g equals r. R is the range or the horizontal displacement of the target from the launch pad. And because we need to find the v, so I have to rearrange this equation. So I will multiply this equation with g, and I will divide this equation with 2 sine of theta cosine of theta. So I will do all of the two steps in one action. So it will become r multiplied by g when I will multiply this equation with g, and these three terms, 2 sine of theta and cosine of theta, will appear in the denominators because I will divide the equation with 2 sine of theta cosine of theta, and when I will divide this term with the 2 sine of theta cosine of theta, they will cancel out each other. So I am left only with v squared. So next I want to find the v, because I don't want to calculate v squared, I need v. So I will take a square root on both sides and I will get r multiplied by g 2 sine of theta cosine of theta square root. Now I can plug in the values and I will get the value of v. But before that, I want you to have a look at the unit of the range, 3,000 kilometers. We know the standard base unit of displacement or distance is meter, not kilometers. So it happens very frequently that they give you a different different or a unit with a prefix in the question. So always keep an eye at the units given in the question, and if there is any unit with a prefix or they give you a subunit like millimeters, centimeters, change it to the standard base unit of that quantity, because this quantity is displacement at distance and SIU base unit for the displacement is meter. So we need to change this into meter. Then our equation will be consistent with the SI units. For example, for the value of G, I will put 9.8 meter per squared. So see, I use meter here. So I have to use everywhere the standard base units, the SI standard base units. So let's change it to meters. So the R given is 3000 kilometers. The prefix K means you have a multiplier of 1000. So we need to multiply 3000 with 1000. So I can write it in scientific notation as 10 power 3 meters. So let's keep it in that form. And now I can insert the values into this equation to find the value of V. So let's get the value of V. I will insert all the values here. Meters, 9.8 meter per second squared, and 2 sine of 45 degrees. They gave us this angle that the missile makes an angle of 45 degrees with the horizontal at the launch pad. So I can use my calculator to calculate all of this expression at once, and it gives me a value of V 5422.18 meter per second. Sometimes you can see the answer of this question in your textbook and you can see that it is given in kilometer per second. It doesn't matter, you don't need to change it into a specific unit until otherwise explicitly asked in the question paper, like give your answer in kilometer per second, which is very rare. But until if they don't give you any such instructions in the question paper, you can leave your answer like this and it's perfectly fine. Or if you like, you can change it into kilometer per second by dividing this expression by 1000 and it will change it. Let's calculate the time. So here I have the equation for the time of flight. T equals 2v sine theta over g. So we have all the quantities to find t. Let's do it. So the time t equals 2 time. Now we need to see the value of v. 5422.18. Always remember, insert the value with a standard base unit. So it's 54.18 meter per second sine of 45 degrees divided by 9.8 meter per second squared. So if I use my calculator to find the value of t, 782.46 seconds. So it will take 782.46 seconds to reach or hit the target. Sometimes smaller units are not easy to understand, like we don't understand how long is this time. it's convenient to convert this time into minutes. So if I divide this value with 60, I get 13.04 minutes. So it will take almost 13 minutes to reach or hit the target. And that is the solution to this problem.